This is Note Taking Guide 2.4. Today we're going to talk about compound inequalities. So first of all, what is a compound inequality? It's really when we have two inequalities together in the same equation or solution set. So we're going to solve two of them at the same time. When we do that, we have two things that can happen. We have an and compound inequality, and we have an or compound inequality. When we have an and inequality or compound inequality, that's when the graph is the solution of both inequalities, or it solves both inequalities at the same time. It's the overlapping part, and maybe that's the word to put right here, is the overlapping of both inequalities. When we're talking about or, when we're doing compound inequalities, the graph is each inequality, meaning it's both of them separately. Because or means that it could be in that solution set or it could be in the other solution set. But when it says and, it has to be in both solution sets. So the graph is overlapping on the and it's the graph of both separate inequalities on the or. So just by what I've said right there on that, we should be able to look at these compound inequalities here and decide if they're ands and ors. Well, these, for sure, this is an overlap because this inequality, this first one, would have been starting here and going less than the 2 in this direction. And this other inequality, it would have been starting here at the -3 and going this direction. So we can for sure tell that that's an overlapping, which means we know that it's going to be an and. So we just have to write inequalities for both of the sets that we can see there. So the first one would be, well, let's just use x as our variable. So we're going to go x, and because this is solid right here, we're going to say is less than or equal to 2, because that would be the graph from here on the yellow down this direction. Okay, and then because we know it's an overlapping, where they're overlapping each other, then our next one is going to be and we're going to write a graph or an inequality for the graph that starts here at -3 with a solid dot and goes in the greater than direction. So x has to be greater than or equal to, because it was solid, -3. So again, that and right there tells me that I can only keep the part that overlaps on those. So that's how I would write an inequality for that graph. Okay, let's go and look at the next one. The next one is this part B right here. And this one you can see is two separate graphs. They're both graphs separated. So we know that this is going to be an or inequality. That kind of makes it nice for us to see that right off the bat there. So we know we have one starting here and going this direction. It started at this solid at 0. So we know our x's are going to be less than or equal to 0. And then over here, we know we're not going to have the equal to because it's an open circle, but we're at 5, so we're going to be greater than 5. So our x's have to be greater than 5. So we just wrote two inequalities there. We knew it was an or sign because they were separate inequalities going in opposite directions. Okay, so let's look at some and see if we can solve it by graphing is really what we're going to do. Some of them we're going to have to solve a little bit before we can graph them. So let's look at this first one and see. So our first inequality is x minus 5 is greater than -1. In order to graph that, I first have to get the x by itself. So I'm going to have to add the 5 over to the other side. So I'm going to have x is greater than, and then -1 plus 5 is 4. So I have x is greater than 4. I have an or sign here, so I know I'm doing an or, which means my graph should be going opposite directions almost always in that case. And then over here I have 6x is less than or equal to 6. This is not solved either. To get the 6 off of the x, I have to divide both sides. So I get x is less than or equal to 1, because 6 divided by 6 is 1. So now I'm just going to graph both of those on the same inequality. I know it's an OR, so I'm going to have kind of two different going opposite directions. X is greater than 4. So open circle greater than 4 is this direction. And then X is less than or equal to 1. So equal to 1 is a solid dot. And then less than or equal to is this direction. So my graph looks something like that. Okay, same thing on this next one. Got to kind of solve it first. And then we're just going to graph them. We know it's an and, so we should have an overlapping part that we're keeping this time. So one kind of sandwiched graph. I like to call them sandwich graphs because it kind of looks like you have a start point, an end point, and everything in between. It's like a sandwich. Okay, I got to get X by itself here, so I'm going to minus the 5 over to the other side. So I have X is greater than or equal to a negative 3. And then I have to solve the other one. So I have to first start by subtracting that 8 over. And I get a negative X is greater than or equal to a negative 6. I have to get rid of that negative on the X, so I'm going to divide both sides by a negative 1. And again, alarms going off in my head telling me don't forget to flip that inequality sign because you're dividing by a negative. Negative 6 divided by negative 1 is a positive 6. So these are the two things that I'm graphing here. All right, kind of what I like to do when I'm graphing these is I like to graph them both and then kind of keep the overlap part for my answer. So the first one is X is greater than or equal to negative 3. So at negative 3, I'm a solid circle. I'm going greater than or equal to, so I'm going this direction. Okay, this one, X is less than or equal to 6. So 6 is over here, over here, equal to. 6 would be like right here, and less than would be this direction. So then what I'll do is I'll write my final answer above that. So my answer is only the parts where this overlaps. So I know that I overlap between this point and between this point because this one's going this way, that one's going this way. So my overlap part or my solution is the part that I have actually drawn in pink here. Okay. All right, let's keep moving on and see what we can do. Okay, this next one is written a little bit different. It's actually written as a compound inequality without an and or an or sign in it. You can see though that there's two things going on here because there's two sets of inequalities. So what we're going to do is we're going to solve them kind of at the same time with some algebra here, where we're just going to do the same thing to both things. So in order to get the X by itself inside here, the first thing we have to do is add the 1. Some teachers will teach you to rewrite this as negative 5 is less than 2x. And then 2x minus 1. I'm sorry, negative 5 is less than 2x minus 1. And then 2x minus 1 is less than or equal to 7. You can write it out that way 2 different ways and then just solve them both. I kind of like to just stick them together like this and do it at the same time. So let me show you what I'm talking about here. I know I have to add 1, but I know I'm solving 2 inequalities at the same time. So I'm going to add it on this side of the inequality. And I'm also going to add that 1 to the opposite side of the inequality. So I have negative 4 is less than 2x, which is less than or equal to 8. Then I still got to get the x by itself, so I got to divide everything by 2. So I get negative 2 is less than x, which is less than or equal to 4. So again, like I said, I like to solve them together like that, where I solve both of them at the same time, but you could have separated them, and maybe that would have been the better way for you to do that if you would have taken these and you would have solved this one right here first, and then maybe taken this one over here and solved it second. You would have got the same answers as me, and you can actually see both of my answers here. My first answer is x is greater than negative 2. My second answer is x is less than or equal to 4. You can see both of them. But the reason I wanted to do it this way is because just a second ago I told you that I like to call the one kind of sandwich graph. And you can see how x is sandwiched in between two numbers here. So to me it's really easy to graph these kind when they're written in this form because I know that I'm bounded at negative 2 and positive 4. And my answers are between that. So at negative 2 it's an open circle because there's no equal to. At positive 4, it's a closed circle, and I'm kind of off the graph, but I'm going to just do it over here at positive 4. And I know I'm sandwiched in between there, so I know my answer has to be in between those two endpoints of where I'm sandwiched. So this is an and graph. I can tell just because of the way my graph ended up being, but again, I like to call it a sandwich graph. All right, the back side of this is review. It's actually a checkpoint. So I'm just going to do a couple of the problems for you, and then you can do the rest of them yourself. So this one, first one, number 1, says to write an inequality. I can tell this is an or right off the bat because I have this or I have that. So I know I need an or written in my inequalities. So the first one, open circle, starting at -2. So I know I have an x and I know I have -2. I know my x's are less than -2. And then over here with my x's, and I know that I'm at 3 where I'm starting, and my x's are greater than 3. So there's my compound inequality. Again, I'm going to let you do the next one on your own. That one's for sure an and. You can tell because it's one graph bounded. It's like a sandwich graph. I'm going to skip over here and do number 4 for you. Number 4 is needs a little bit of work to be solved before you can graph it. So the first thing we're going to do is add the 8 on this inequality. We get x is greater than or equal to 10. And then on this one, we got to get rid of the 8 by multiplying. So we multiply both sides by 8. And when we do that, it cancels over here to be x. And then that will be less than 8. So this is an OR graph, so I should be going opposite direction. So I have x is less than 8. So at 8, open circle, less than direction. And I have x is greater than or equal to 10. So solid dot going the opposite direction. And I'm just going to do one more of these last 2 for you. You can go back and finish the rest of them yourself. These are both compound inequalities, so they should be the overlapping part. I'm just going to do this one right here. I'm going to add 7 to both sides of that because it's a compound inequality. -6 plus 7 is 1. And then 3 plus 7 is 10. So I can see that I'm bound between 1 and 10. At 1, it's a solid dot because of the equal sign. At 10, it's a solid dot because of the equal sign. And then I'm just bound in between there because this is a sandwich graph. So finish those problems on this back page all by yourself, please, before you go on to your homework. Good luck on your homework today, you guys. Thanks.